The previous problems were so-called statically determinate problems. In contrast, the next topic is about how to solve the statically indeterminate problems. So, before moving on to the next topic, I would like you to be clear about the difference between statically determinate and indeterminate problem. In the problems so far, statically determinate problems, we directly found the stress due to the load P. Once the stress is found, the strain can be calculated by dividing it by Young's modulus. A statically determinate problem can be represented, for example, by the situation in which an external force F is acting on the two springs in series, as shown in the illustration. When an external force F acts on these springs, the load acting on each of these two springs is also F. In such situation, the total elongation is the sum of the elongation of the left spring and right spring. So, in this case, F is not an unknown quantity. We can directly obtain the value of load acting on each spring as F. So, the problem can be solved in the following way: from the load to stress, from stress to strain, and then strain to total elongation. However, in the statically indeterminate problem, the answer cannot be found through such a process. The next problem, statically indeterminate problem, are represented by the illustration. In this case, springs are connected in parallel and external force F is acting on the springs. Here, you may notice that the loads applied to each of the upper and lower springs cannot be directly found as the case of statically determinate problem. So, the procedure to solve statically indeterminate problem starts with defining the load on each spring as unknown quantities. Then, focusing on the fact that elongation of each spring is equal, we determine all the deformations and loads by using conditional formulas that describe the sum of the loads at each spring is F.